give you kind of heads up what's going to happen today. My goal is to finish our last section, regression line, number 3.
I have a question.
Go for it.
I know you talked about it, but my brain just totally spaced it. How do you test again in this class? I know it has to do with the PDF, but then I was thinking.
Okay. Very good question, because you beat me. You kind of stole my thunder, which is good. Today we are going to finish off regression lines. About 15 minutes before the end, I'm going to talk about the test. So all those things you're interested in, that's kind of when I decided we were going to do it. So I'll hold off my answer till then, right? But I was planning to do it. Because there's a lot of things that I need to tell you, so I'll need about 15 minutes to go over everything. And if we need more time, just keep asking me questions till everything you want to know has been given to you.
Okay.
So we did regression lines, right? We've done a lot of stuff here. So I'm just going to kind of add to that, and then we'll start looking at what the homework questions look like. And then we'll finish and we'll start looking at things to do with the test. I need to, here we go. So let's assume that I collect data, and it's going to be called X and Y for a minute, but let's say the data is age, and let's say X is age and Y is your height. And we collected data on, I don't know, hundreds and hundreds of teenagers, right? So kind of 13 to 17, 18, 19, right? 13 to 19-year-olds, and we collected the data and we did a scatter plot. I don't think it would be unreasonable that your scatter plot might look something like this. Would you agree that most people, the older you get, right, the taller you are, right? So the x-axis is your age and the y-axis is your height. Which one of these two would be called the explanatory variable, and which one of these two would be called the response variable?
Age would be the explanatory.
Yep. And there are some homework questions where they ask you that. Are we quite comfortable about x-axis is typically explanatory variable, y-axis is the response variable? If it was a table, wouldn't the top row typically be the x, and so that's explanatory, and the second one would be the response? When they do tables this way around, the one on the left, isn't that typically the X, and the one on the right is the Y? So the look of the table, doesn't that tell you response and explanatory? And it's a lot easier when it's a guy like that. And let's suppose they did a nice straight line through the data, and I may have to change some of my points to make it realistic. And that straight line had a correlation coefficient of 0.8. Right, and we talked about that. Agreed? Now, that would probably qualify as strong. Agreed? There's another guy called R squared. Its fancy name is the coefficient of determination. Remember that one? R squared? Now, its name is a strange name, but isn't its name very helpful, because it's obvious what you need to do? To get this guy, don't you square this guy? But we typically use the percentage value of it. It's almost always, R squared is almost always given as a percentage. Right? So this is us doing basically a recap. Does that sound familiar? You remember doing this, right? And there's a funny sentence that we sometimes use with that. Don't we say that 64% of the variation is accounted for by the model? In fact, don't you keep the same sentence, but just change the number at the front? So in a different question, it might be 20%, in which case 20% of the variation is accounted for by the model. Isn't this number quite a good number to get a kind of ballpark figure for how good this data is to being fitted by a straight line? So 64% might not seem great to you, but that's actually pretty hard to get, right? I've seen 90%. 90% are really good. Can you imagine 90% would be like a 90% fit? And if I used this, if I knew it was a really high number, don't you also get equations that might be looking something like this? To put a little hat on them sometimes. And I'm making this up, so pay no attention to the numbers because it won't be realistic. But imagine it was that, right? Okay, just for argument's sake. Now, I would call this guy the height and call it 14 plus 2 times your age. And sometimes they write it down like this, the ones with the words. I like them better, but some of the questions are going to look like this with the X's and Y's. Well, you realize there's the same thing, right? They're just two different ways of writing the same straight line, okay? Now, if I give you an equation like this, are we comfortable that you could use it to predict what a typical 17-year-old would be in height? Right, you plug 17. If you wanted a 13-year-old, you would do that. We all agree we're comfortable with that. Now, if it's a really good percentage, won't we be really comfortable that this estimate is probably accurate? But if this R squared was 2%, wouldn't you probably not even bother using the formula? Because 2% right is also 98% wrong. I mean, if you look at it from the other side, I don't want to do something where 98% of the time I am wrong, all right? Because that's probably not a good success rate. So it's not strictly correct, but it's a good kind of way of looking at it, isn't it? 64% of the time I'm going to be pretty close to the right answer, right? That's better than 50-50, right? So it's better than guessing, right? So it's good. Are we cool with all of this? Because this is still me on revision world, right? Just stuff that we covered last time. Okay. So I'm just going to add some extra topics and ideas to this thing. And it all boils down to a very common mistake that people make when they create regression lines like this. The whole process is called regression analysis. It basically means you take some data, you do a scatter plot, you make a straight line go through it, hopefully a straight line go through it, you get an equation, and then you start using it to predict stuff. And that's great. But a lot of people then do one more step. And sometimes that step is correct. It would be reasonable to assume that your age, right, is causing your height. In other words, the older you are, the taller you're going to be, right? And that's a cause and effect, right? The cost of gasoline is going to have a direct effect on how many miles, how many gallons of gasoline you're going to buy, right? Be silly about this. If gasoline went up to $30 a gallon, do you think you're going to buy the same amount of gasoline as you would this week? Would you agree that it's going to have an effect, right? So those are examples where it does have an effect, but this is the sentence I'm getting at. It's called correlation does not always mean causation. So just because you've done a table and it's a really good straight line and there's a great fit, it doesn't always mean that age causes your height, right? Age is the main reason why you are the height you are, right? So I'm going to show you two examples. They are silly examples, but they get hopefully they get across the idea that just because the data is a good fit, it doesn't mean the X's are causing the Y. So here's my first one. Someone collected data on the shoe size of children, right? So 5 to 10-year-old children, right? And they measured their shoe size, right? You're a size 4, you're a size 6, right? Whatever those numbers are. And they measured it against the reading age of that child. So you got children read it, a 6-year-old, you know, a 7-year-old, an 8-year-old, you know, 9-year-old, whatever, 10-year-old, and so on, right? And here they get shoe sizes. I don't know shoe sizes of kids. Can we pretend it's 3, 3.5, 4, 4.5, 5, 5.5, whatever, right? Shoe sizes. Now you collect the data and it will look a bit like this. It'll be pretty strong, right? Linear and a really good R value. You might get an R value of 0.9, which is a really good R value. What's that? 81% fit, right? And then someone says, I now have a cause. I now can say that shoe size causes your reading age. Now let me try and explain why that's not the case. And this is where the silliness comes in. Suppose shoe size was what made you good at reading. Then if you are a very cruel parent and a very rich parent, and your child hadn't a very good reading age, right? They were 10 years old, right? And they're still reading like a 4-year-old, right? Couldn't you go and get an operation where they break your child's foot and stretch it out and make them 2 shoe sizes bigger? Would you expect that child to be any better at reading after that horrible operation than before it?
Isn't
Do you
that
see
an
that?
actual surgery?
I
Like that's
hope.
real.
I hope. Well, maybe for good reasons, but not for this reason, right? Can you see then that really your shoe size isn't why you are the reading age that you are? The real reason, right? The real guy is called a lurking variable. Not my name. I like it. It's a good name. It's called a lurking variable. Can you think of what might be the lurking variable in this story? Why are children's shoe sizes, as they get bigger, why are those children's reading ages getting bigger?
I mean, normal development?
Yes. Don't older children have bigger feet than younger children? Don't your feet get bigger as you get older, just like your height gets bigger? So the lurking variable in this case, I would assume, is more likely to be the age of the child. So couldn't you go back and just collect what age is that child and then what's the reading age? In that case, wouldn't you expect most 6-year-olds to read as a 6-year-old and most 8-year-olds to read with a reading age of 8? Now, that's not perfect. Aren't some 8-year-olds very good at reading, right? They read at a 10-year-old level, right? And some 8-year-olds aren't as good and they read at a 7-year-old level, right? But wouldn't that data fit linear and be just as good as this? But wouldn't that be a more realistic reason for the connection? So correlation, that means nice straight line of data, doesn't always mean that this variable is the cause of that one, right? The explanatory variable is really the one that's truly explaining what's going on, right? Now here's my second one. This one is true. The data might not be perfect, but the reasoning behind it is true. You go to various countries in the world and you find out the average number of TVs per household. And on this one, we do the life expectancy. So in a place like America, let's just do, because the males and females are different. So let's do males, right? I think the life expectancy in America for males is early 80s, like 81, 82, something like that. And for females, it's like a couple of years more. It's like 83, 84, right? So can you imagine 0, 1, 2, say 3, right? And let's say that's 90 and this is 80 and this is 70 and let's say this is 60. Then America might have average number of household TVs. It might be a way up here, right? That's America, right? If you collect data on lots of different countries, you will see this. Pretty good linear. Probably moderate. That looks a bit stronger than it would be in real life, right? Does that mean that the average number of televisions in your household makes you live longer? Clearly not. Would you agree? I mean, if that was true, wouldn't America not be sending medicine and doctors and food aid and all sorts of things to lots of places in the world? Wouldn't we just send them TVs? I mean, if it was true, I'm being silly here, but wouldn't that be what you would do? So it's pretty obvious that that's not the cause, right? That's not causation. So think about it for a minute. What do you think this is measuring that is the cause of this?
Wealth.
That's what I would pick. Now, it's kind of indirect, but this is my argument for why I think the lurking variable here is wealth. Do you know you can get a number in wealth? It's called GDP, right? Gross domestic product, right? You can get a number for every country and average it amongst the number of people who live there. And you can find wealthy countries and poor countries. Right. Wealthy countries like America can afford lots of TVs. Typically, don't wealthy countries have enough food for everyone, or mostly everyone? Don't they have lots of access to doctors and hospitals? Well, a lot more than poor countries, right? And don't all of those things tend to help you live longer? So if you were a country where the average TVs per household was 0.1, in other words, a really, really poverty-stricken country, would that same poverty-stricken country have not a lot of food? Probably. Very few doctors, very little access to medicine or hospitals, probably a very rough lifestyle. Won't they probably work in quite harsh conditions? And won't all of them reduce their life expectancy? So correlation does not always mean causation. And why is that a biggie? Because scientists screw that up sometimes. They have an X and a Y, and it's a really good straight line, and they say X is causing Y. Politicians do that deliberately, even although they know it's a lie, because it helps their political view, right? So you get data, and they will say, scientific evidence proves that there is a strong correlation between A and B. And they say it so that you think it means that A is causing B. And it might not be. Couldn't it be a totally something else? But the A that they mention is the one that they like to be the cause of B, so that they can make laws to stop you doing whatever A is, or they can get money to fix whatever A is. And I can get my little dig in about politicians. A couple. First one is, I don't like politicians. You probably know that. I don't like laws in particular. I do find they unnecessary, right? I think it's a good idea that there's a law that you're not allowed to murder someone, for instance. I like that law. But I don't like a lot of laws because my viewpoint is every time the government passes a law, don't you lose a little freedom? There are very few laws that say you can now do something that you weren't allowed to do. Aren't most laws you're not allowed to do something that you used to be able to do? So I don't like those. And if they are making laws under the assumption that A is causing B, and it wasn't really A that was causing B, haven't they just made a law up to make themselves feel better, like they're fixing something, when they haven't fixed anything? And secondly, when governments do programs to fix things, do you know that they never fix things? All they do is create a whole load of jobs and bureaucracy connected to that. I mean, if the government wanted to get rid of alcoholism, they set up places, right, to treat alcoholics. But does alcoholism ever disappear? No. Now, there are lots of ways of curing problems, and this is me getting my politics out of the way, but I have to do it because it's in my brain. Do you know the easiest way to reduce certain types of crime? Do you know the simplest way? I'll give you an example. Suppose I wanted to make people finish high school. Do you know the best and most efficient way? Give people money for going to school. Pay them to go to school. Do you think that would increase the attendance rate and give them a bonus when they graduate? So what do governments do? No, they don't do that. Don't they spend millions on aftercare programs and before care programs and tutoring programs and mentors and counselors and 1,001 other things that cost a lot of money? Wouldn't a lot of them just like $200 a week and I'll come to school and give me 10,000 when I graduate? Do you know that would be a lot cheaper? You just thought I'd put that out there. Back to the reality. Just because X and Y look like a straight line, X doesn't necessarily cause Y. Be on the lookout for lurking variables. Sometimes X does cause Y, but be on the lookout for it. Okay, I got me rant over with, but I feel better.
Robertson,
Yes.
are we going to be asked on the test, like, what is the lurking variable?
Yes, but the good news is, if it's a good answer, even if it's not mine, I'm taking it. Because it is kind of subjective. If I give you that question, now, a lot of questions I won't be giving you. Right, so what I want to do now is quickly jump over to the homework and show you what the homework in that last section looks like. And I apologize for the speed of this, but hopefully we've covered everything really. So hopefully I've covered everything. So here it goes. Which one of these following numbers could not be a R value, right? A correlation coefficient. Which one of these numbers couldn't be one? And there's a couple of choices. There's the list. Make it a little bit bigger if you can't see it. Give me a number that couldn't be an R value.
2.8.
2.8.
Agreed. Where's the other one? Because there's two.
Negative 1.2.
You remember R has to be between -1 and 1? That's all that was. Okay. Remember that R squared can be considered as a percentage, okay? Determine which of the following could not be R squared. Oh, God in Himmel. Can I kill every single one of them because they're not a percentage?
It says proportion or as a percentage.
Oh, then I take it back. One of those four should be checked off. I've kept it in just to show you it's a mistake. One of them is not allowed to be r squared.
1.7.
I've kept another one in. Which one is not allowed?
Negative 0.25.
You'll never get a negative. Now, 0.3 can happen, and so can 1. In fact, aren't they very extreme values? Wouldn't r squared be 1, would be 1%? Well, 1 as a ratio would be 100%, I should say. Wasn't that a perfect straight line? And 0 would be like nothingness. No, yes, no. Why can't 200% be an answer?
You can't fit something 200%.
Right, isn't r squared going to be between 0 and 100%? And isn't r going to be between -1 and 1, right? Here are stories about positive and linear and perfect nonlinear. I think we've covered those guys. Here's a story. Okay, this one we have. Well, I'm hoping we can do this one. Which of these is a stronger linear relationship? And don't jump in. Think about it for a second before you jump in. Positive 0.3 or negative 0.8. Which of those two is the stronger linear?
Negative 0.8.
Agreed. Isn't that just a strong downhill one? Isn't it better than a weaker 0.3 going up and negative 0.8 coming down? Right. So doesn't the value of r, whether it's plus or negative, is a strong indicator of strength? Okay, here's some data where they looked at right hand, left hand. Evidently, people, when they stretch their fingers out, it's called the span. The correlation coefficient is really good, right? Would you agree 0.95 is really strong? Surprisingly, how that doesn't look tighter. But, you know, that's what 0.95 looks like, right? What would happen if we converted all the data into inches? What would the correlation coefficient look like?
It should be the same.
Yeah, doesn't matter. Correlation coefficient is independent of units. So you can measure people's height in inches and feet or centimeters. You can measure their weight in terms of kilograms or pounds or ounces. You still get the same R value, which is very useful because being independent of the unit of measurement is a very strong property. Would you agree? It helps you understand the connection, and it doesn't matter, well, if you measure in inches, it's not that accurate anymore, right? It's just as accurate every time.
What if somebody changed the right span to meters but left the left span as centimeters?
It would, strangely enough, still be the same R value. So that's good news. I wouldn't want to do that, but if you did, it would still be the same R value. So it's very resilient to units of measurement, right? It doesn't really care what you call them as long as you're consistent, right? Okay, let's look at these four. Which one of these four would have the strongest R value, the strongest connection?
Graph 2.
I agree. Would you agree 2 is the closest to being linear, right? And then we have various versions of getting weaker. And so you figure out which one of those is the weakest. Oh, that's a good question. Which one of those graphs, 1, 3, or 4, is the weakest? And you might be surprised by the right answer.
I'd like to say 4, but now you've got me questioning it.
I think it's 3.
I agree, it is 3. Now you might say, but it's very organized, which it is, but isn't it very organized in a non-linear way? Couldn't you do a line going down the way, a line going up the way, a line going horizontal, a line going vertical? Couldn't you do any kind of line and it would fit probably just about as well as any other line? right? Corner to corner, corner to corner. So that one would be my best guess at the worst one. These guys are very weak. I'm not arguing with that. I mean, I make numbers up. That's like 0.2 and that's like 0.1. But this guy here would be like 0.01, right? It'd be almost nothing. And similar question, so I'm not going, oh, well, I take it back. They do put numbers on these. So if I was looking at graph 2, would you agree that I would, well, graph 2, would you agree I would be picking that number out of the 3 choices? Now let's see why. Isn't that the only one that's strong and pointing downwards? Are we good? Right. Here's fill in the missing words. On average, the verbal skills of children under 12 tend to improve or get worse or remain stable. So they give you some stories and you fill in intend to improve, and you would expect to have a positive correlation, right? If things get better, don't you go uphill, and uphill means positive. If things get smaller, don't you go downhill, and downhill means negative. So basically, you've got a story, and if that one gets taller, it would be positive. If you believe that gets shorter, then that would be negative, right? That would be the pairing. We've covered that, and we've covered that. We've done SALT. We've talked about outliers. There's another SALT and table. We have covered questions where we've done equations, right, and you plug in numbers. So in this question here, if you plug in 2 feet, won't it give you the success rate? If you plug in 20 feet, it'll get you the success rate. And then there's another one of, as that gets higher, this gets lower, and so on. And then you pick a picture. Same kind of question again. Yeah, let's pick this one. Based on the data for the past 50 years in the United States, there is a strong positive correlation between yearly beer sales and yearly per capita income. Okay, so the more money you make, the more beer you buy. Does that sound a reasonable connection? Right, so x-axis, explanatory variable, more money I've got. Y-axis, how much beer I buy. So figure out which one of those sentences is the same as is the main reason behind that. And then there's full of little stories like this. And then we got obesity. The obesity rate in 1975 and now the obesity rate in 2014. And it's basically linear, although I would say curvilinear. Would you agree with me? That looks more curved than it looks straight, especially at the end. Yeah. So there's a question in here where you would use the word curvilinear. The fact that they put a straight line through the data is a bit of a distraction, isn't it? Because then you tend to see straight lines when somebody draws a straight line in a data set. Here's some more stories about things getting fat, and we are looking for lurking variables here, aren't we? Okay, last question. Researchers have shown that there's a positive correlation between average fat intake and the breast cancer rate across countries. So countries that eat a lot of fat tend to have a higher breast cancer rate than countries who don't eat as much fat. Okay. Does this correlation prove that eating fat is a cause of breast cancer? All right, so you did the data, eat a lot of fat, you get a lot of cancer, right? Over lots and lots of countries. Think of the TV against life expectancy. What could be the main, another cause? and they give us some suggestions, right? You could say no, it doesn't indicate it. However, this actually implies that having breast cancer causes people to eat high. No, I don't think that's a true one. I'm kicking that one out. How about no? A positive correlation would be caused by other variables. These other variables are the lurking variables they're talking about. Can you imagine if you eat a lot of fat, right? What kind of person might eat a lot of fat? I'd describe them as probably couch potato, right? They probably don't exercise a lot, right? Eat a lot of fat, don't exercise a lot. Maybe they have other bad habits. Could you imagine that maybe they smoke too much, or maybe they, they do other things. Lack exercise. Maybe they take a lot of sugar as well as a lot of fat, right? They eat a lot of cakes or whatever. Couldn't it be the sugar that's caused the breast cancer? Couldn't it be lifestyle? I mean, you see, there's tons of other reasons it could be causing it. If they think that that was a real cause, right? If they thought too much fat was causing breast cancer, wouldn't doctors today be saying, look, Pete, stop eating fatty foods. It's going to give you breast cancer, right? It's going to increase your chances of getting it, right? Now, I honestly don't know a lot about that type of cancer, but I'm guessing genetics is a strong factor. Would you agree if your mother had it, although men can get breast cancer, by the way, if your mother had it, isn't there a stronger chance you're going to get breast cancer? So genetics is a very strong lurking variable. Would you agree? That I think I know about. Now, I don't know other causes of breast cancer. Maybe fat intake is one of them, but I would probably put that down to maybe overweight might be a cause or a contributing cause. But it might be genetics is 50%, overweight is 5%, don't do an exercise is 10%, all the different things. So it doesn't necessarily have to be one lurking variable. Couldn't it be 2 or 3 different ones all in combination? And so that's the last thing I want to get across to you, is that when you do these scatter plots and you see nice linear data, don't assume that X is causing Y. Think there's a connection there, but it might be another reason, a lurking variable reason. And if you can find that lurking variable, now you've got a piece of information that might help you reduce breast cancer. I'm not sure what you could do about the genetic one, although I believe some women, don't they get an operation where they just remove them anyway, right? Just to be safe, and that way they can't get it. But there might be other better cures than that. We are finished as far as what you need to know. So I promised you, and yeah, I wish I'd given myself more time. I hope you can hang about for the rest of this. If you can't, will you at least watch the end of this video so you can find out what the other questions were? But I ranted on a little bit, and that was me, and I shouldn't have. Okay, if you can bear with me a few seconds, I'm going to be eventually finding the right window to open. Your test is going to be on Monday, and you're going to turn up to class as always and do a Zoom meeting, just as we always do. And the test will start. And move that over here, go into student view, close that window, and open it up, and let's show you, hopefully show you what the heck's going on. Okay, let's try that again. Right, hopefully you're looking at Canvas site. Okay, now, there's a new guy in town called Test 1. You're going to get the test on Monday. It's going to be here. So when you click on this, the test will be in here, and it will be a PDF. Analogy, imagine you turned up to class and I wrote the test up on the whiteboard, right? So you're going to read it and do your answer on paper, not like WebAssign, right? So I get to see all your working and all that good stuff. So it's going to be in here. You won't see it because I won't make it live until 11 o'clock, right? When the test starts. And then when you go into Canvas, it'll be there. Now, once you've done it, you then have to basically turn it into a PDF. So watch that video on how to use Adobe Scan, if you haven't already, and use this link to download it. And all Adobe Scan is a little app. You can have it in your Apple phone or you can have it in an Android phone. And basically, you take pictures of your work and it turns them into PDFs. And the PDFs can get joined together and you can send it to me. Now, you don't need to do that. You might have a printer that scans stuff and turns them into PDFs. Use that. You may have another piece of software, because some English professors do the same thing. You might have Cam Scanner as an example, but there are others. Use that. I don't care how it becomes a PDF, I just need it to be a PDF. Any questions so far?
Yes, I have a
Go for
question.
it. Yeah.
So we have 50 minutes to do the test, turn it into a PDF, and upload our work.
No, a little bit more than that.
Okay.
So what is going to happen is that you'll basically get the entire hour to do your test. So that'll be 11 till 12. And you then get another 30 minutes to do the picture thing and upload it into Canvas. So that's why it says the deadline is 12:30 p.m. Now, you won't need, most of you will not even need that hour. Most of you, you'll be done in about 45 minutes. And so you'll probably be able to do everything within the hour that the class lasts, right? If you, however, have a class directly after this one and that time slot doesn't suit you, right? Because it might not, then you just contact me and we can arrange an alternate time for you to do the test so that you're not, you know, it's not butting into something that happens after 12 o'clock. Akila, do you have a question?
Yeah, so do we just like have the Zoom class open and the PDF open on a computer at the same time?
Yeah.
Okay.
Once you've got the PDF opened, you don't need to worry about Zoom. I have to see you. So make sure you've got your video going. The reason I need to see it is for security. I want to make sure that you haven't got somebody beside you who's very quiet but doing the work for you, right? So that would be cheating, and we're not allowed to, and we don't want cheating, right? So you get it and you upload it. Let me show you how the upload would work. It's not perfect, but I'll show you what to do. So you've finished your test, you've got it turned into a PDF, you want to get it to me. So you go into Canvas, you click on that, and you see where it says start assignment? You click on that, choose a file, and you know, wherever you've got it. You've got it on your computer, it's on the desktop, you got it on your phone, but you've stored it somewhere. You pick it, you say that, and you submit assignment. In a few moments from now, it should hopefully, yay, it's done, right? Now, practice that. So just take a picture of, I don't know, an elephant or something, right? Turn it into a PDF with Adobe Scan. Go in there and practice uploading it. Don't worry about it, because when you upload your test, it rubs out everything and all I see is the test, right? So you can upload it and, you know, try 2 pictures to turn in, you know, into a single PDF. Get comfortable. If you get comfortable, it literally takes 5 minutes to do, right? 3 or 4 pages, take pictures, PDF, into Canvas, upload, done. So your day is going to be a little bit longer for some of you. You have to be on Zoom during the entire process. So if you take a little bit longer, you know, like you use the whole hour up to do the test, you still stay on Zoom until it's in Canvas. And once it's in Canvas, it's gone. So I'll make up a scenario. You did the test in 40 minutes. Took you 10 minutes to get it uploaded in Canvas. I've watched you the whole time. I know it's good to go. I go in and I can see it there. I'll say, we are good to go. Bye-bye. And you're off, right?
So I could like go over to my printer and like,
yeah, you might, if you've got a printer, you'll say, I'm off to my printer. I'll say, fine. I'll you know, I'd be very suspicious if it took you 25 minutes to come back, but I would expect you to come back a relatively short time and double check, and I'll say good to go, and you're finished. And Zoom's also helpful. If you read a question and you're not sure what the heck it's about, you can say, what are you asking here? And I might be able to rephrase it in another way. So far, so good?
One more question. Do you prefer to ask questions through chat or just pop on and ask?
I prefer chat because I'll make up a scenario. Is the lurking variable age or is it food? Well, in a way, you've told people the answer, haven't you, in that question? Right, you've mentioned lurking variables and some suggestions, and that would be, well, you might not think that's a bad thing, but it would be kind of unfair, you know, to people who did it properly. So, but I mean, if it's something totally nondescript, if you know it's no way in the world is this going to give anybody a clue, then it's actually better if you do. Is that number 47 or is that a plus, or, you know, things like that? I can do. Or, yeah, I think it would be okay as well to say, what is this question asking me? And then if I give you a different way of saying it, I think that's being fair because everybody might get the same advantage then, right? But if it's something specific to an answer that you've got, I think that's much safer as a chat question, just to be safe.
So just message you privately on the chat?
Yeah, just do it through chat, private. You know, you can do a private chat so only I see it, right? Rather than a general chat. I would make sure you do that. Right, I'm not quite finished, but I'm definitely close to being finished. I'm still trying to find one more page. For some reason, it's disappeared on me. So if you bear with me while I'm doing this. While I'm setting this up, there are a couple of things I should tell you. WebAssign will disappear. So you won't be able to go in and look at any of your WebAssign homework questions because I'm going to be using questions very similar to that in the test. So it's not gone forever. I'll bring it back after the test so you can still see your stuff, right? You are allowed to use TI-84. In fact, I guarantee you will use it, or some calculator. You are allowed to use SALT. Well, not SALT. Take that back. You won't be allowed to use SALT, but you will be able to use the calculator that does standard deviation and means and things like that, right? You won't be able to use SALT because it isn't going to be there. And you are allowed, right? You are allowed to use anything physical that you've written down. So if you've written down good notes on how, you know, linear correlation or whatever the darn thing is, then it's totally fine, right? So if it's physically written and I see you reading notes, I'm going to be okay with that, right? I should warn you, if you have to look at notes for every question, you won't get finished in time. So most of the time, having the notes is very psychologically relaxing for you because you just say, yeah, I was right, and then off you go, right? You don't need to spend a lot of time on it. Okay. Working is important. For those questions where working is necessary, I need to see it. So that's not always the case. Do you know sometimes you just put the data in and the calculator tells you that the mean is 42? I totally understand that. The answer's 42, you can't really show me working. I don't expect you to write out 50, you know, well, it would be 50 numbers anyway, but 50 numbers with a plus divided by 50. I don't need to know that. It's a calculator thing. But there are some situations where you do calculations, right? And for those that you have, I strongly suggest that you do that. There are going to be questions where you're given graphs and pictures, and all you're going to do is tell me which guy's an outlier or something. That doesn't require working, right? So if you're not sure, do I need to show working for question 3? Well, you just ask me and I'll say, nope, the answer's good enough. So I'm now ready to show you. Oh, darn it. Excuse me. I said darn it. I didn't swear. Gotcha. The last thing I want to show you then is this fellow over here. which let me get into it. And that is, what is your homework and what is your test going to be covering? Right. Your test, first your homework. This is what's due midnight Sunday. You are not going to get any questions on getting started with WebAssign. I think that's pretty obvious that that wouldn't be a reasonable question. But you will get questions on these topics. But you're only going to get 4 questions. So it could easily be that some of these questions some of these topics don't get asked as a question, right? And that's fine, right? Quite a few of the questions are going to be A, B, and C's to them, as you'd expect. I think I've covered everything. You want to tell me something? Yeah, just ask me a question, because it could be something I didn't mention or I could have done better in explanation. You know the test?
So I've been using the TI-84 on my phone as an app recently. I'm assuming that you'd prefer that I use the actual calculator, right?
No, because when you're using the TI-84, isn't the answer just going to be what the calculator tells you? There isn't any working associated to it, so I don't care.
Yeah, okay.
Okay. I would be a little bit concerned if I thought you were looking up the internet, because that's not allowed. But in the calculator, that's fine. Any other questions? Okay, we all say hi, and while you're saying hi, I'm going to finish by telling you this weekend you belong to me. No boyfriends, no girlfriends, no wild parties, no going out for a fortnight or whatever. You are going to be sleeping for 2 hours. Nakia, you're just going to give your child away to a stranger for a couple of days, right? No, nothing but getting ready for this test. I want you to come to test 1, and you're going to laugh at it because you're so well prepared, it's easy. That's what I want, right? And you don't get that by not doing your homework or getting, really putting in the effort, right? But I will allow 2 hours sleep Saturday and Sunday, right? That's it. That's all you're allowed. And you now know I'm joking, right?